All right, I'm officially recording this now. All right, so we did a couple of the problems from the booklet for the review book for the multiple choice. I did exam 4, problem number 4, which is right here. You could pause this video now to go through that. And I also did problem number 3, which asks for vertical tangents given these x and y equations based on t. We talked about vertical tangents occur where dx dt is equal to 0 and dy dt is not equal to 0, because really it's where the derivatives denominator is equal to 0 when the numerator is not. So we found that that's going to be true at t equals pi halves and 3 pi halves, which is then going to be at the points -1, 4 and 7, 4. Okay, so that was again from sample exam 4, problem number 3, and then we did problem number 4 down here. Okay, now what else would you like to see? You want to cover a little bit more from, yeah.
Problem number 10.
Number 10 from exam 4?
Yeah.
Okay. So here we are, still exam 4, number 10. Okay, this one is it seems to be an area problem. And this one says, let R be the region in the 4th quadrant. So 4th quadrant, let's go ahead and put that up there now. 4th quadrant, right there. Delete that guy, get out of here. Okay, 4th quadrant, enclosed by the x-axis and the curve y equals x squared. So I have y equals x squared minus 2kx, also known as x times x minus 2k, right? And they tell us that k is greater than 0. So I know that this guy is hitting here at 0 and here, which is what I'm calling 2k, right? And I have this parabola that's like that. And this, my friends, is that region. If the area of the region R is 36, find the value of K. So if the area is of R is 36, find the value of K. How would I find this? Again, this right there is y equals x squared minus 2kx. If the, and this is R, and the area of R is 36. Well, how would I find the area of R? So area of R is the integral from 0 to 2k. And then because this lies underneath the x-axis, but they're talking about just the area of the region, I'm going to make the whole thing negative this of, well, I guess what I could do is I could do this. I was going to, let's do it this way. Now, this is top minus bottom, so that's going to be 0 minus quantity x squared minus 2kx. I'll do it this way. dx equals 36. I was going to say negative this integral from 0 to 2k of just x squared minus 2kx equals 36. But I now am thinking about it as top minus bottom, where top is just the x-axis, also known as y equals 0. So now this ends up being, so this implies that, let's call it negative x cubed over 3 plus, and that's going to be kx squared going from 0 to 2k equals 36. So where am I getting this from? Well, you know, this whole thing right here, let's go red. This whole thing is negative x squared plus 2kx. Negative x squared's antiderivative is negative x cubed over 3. 2kx's antiderivative is 2kx squared over 2. 2's cancel out, so that's just kx squared. So now I have, this implies negative 2k cubed over 3 plus k times 2k quantity squared minus, and then when I plug in 0, this is all just 0, is equal to 36. So this implies that negative 2 cubed is 8, so negative 8 thirds k cubed plus 4 k cubed equals 36. Well, 4 is also known as 12 over 3. So this ends up being 4 thirds k cubed equals 36 times 3/4 times 3/4. Well, 36 divided by 4 is 9 times 3 is 27. So I get k cubed equals 27. Cube root of each, k equals 3. Okay, so they were looking for the k value, and for this, k is equal to 3, which is the answer B. All right, so that's how to do that problem. Anything else? Yes.
Number 11, please, on the same one.
Same one, but problem number 11. Let's do it. Number 11. Number 11. We have a limit, and it says limit as h approaches 0 of 1 over h times the integral from 0 to h of sine squared t over t squared dt. Okay, so this is like, whoa, what are they throwing at me here, right? Again, you're always looking per problem, you're saying, what concept are they testing? Because we know all the concepts, right? What the concepts are. So once I have identified what concept they're testing, then we can like focus our brain on, those concepts. So here I see two main things. I see a limit, and I also see this, this integral right here, right? And so I would first rewrite this as the limit as h approaches 0 of just the integral in the numerator divided by h in the denominator. Do you see that that's the same way? I mean, I'm just rewriting it. Instead of 1 over h times, I'm saying whatever that integral is divided by h. And now check this out. I have, when I use direct substitution, that the numerator is just 0, right? Because as h approaches 0, if I plug in 0 in for h, it's the integral from 0 to 0 of something dt. Well, that's obviously going to be 0. And then when I plug 0 for h into the denominator using direct substitution, I get a 0. So I have 0 over 0. So here's how I would indicate that if I were writing this on the AP exam, right? I would say limit as h approaches 0 of the integral from 0 to h of sine squared t over t squared dt equals 0. And I'd also say limit as h approaches 0 of h equals 0. Therefore, by L'Hopital's rule, or you could say is equal by L'Hopital, the limit as h approaches 0 of the derivative of the denominator is just going to be 1. What's the derivative of the numerator with respect to h? Yeah. Yes. Sine squared h over h squared by what? The fundamental theorem of calculus, right? So that's what we got. So now when we try to apply the limit, guess what? We get 0 over 0 again. So I would say limit as h approaches 0 of sine squared h goes to 0, and limit as h approaches 0 of h squared goes to 0. So guess what I'm going to do? Therefore, by L'Hopital's rule, notice I'm giving it to you 3 ways, right? L'Hopital is written like this with the O with that hat. It's written as, just LH over here over the equals, or by L'Hopital's rule now with that O with the hat written as the OS, right? They're all correct. So this is now the limit as h approaches 0 of. What's the derivative? Now, this denominator goes away, and so I have this is the numerator, and this is the denominator. So as we are looking at this, what's the derivative of only the numerator? Two sine h cosine h. And then the derivative of the denominator is 2h. Man, they have us do this again. So now when I do that, I have 0 over 0 one last time. Gosh.
Any more ways to write it?
No.
Who's a Joe?
How about this? Limit as h approaches 0 of. Now, the denominator is just going to be 1. What's the derivative of sine h cosine h? Well, that's the first times the derivative of the second, so negative sine squared h, plus the second times the derivative of the first, so it's plus cosine squared h. Now when I plug in 0, I get that that's 0, that's 1, so this whole thing is 1. Oh man, that was a long problem just for that. Let me see. What problem was this again? 11. Here we go. So that's going to be C. Let's look at what they have for the answer document. Oh, look at what they did. And I should have seen this too. So at this point right here in the blue, do you see how this is equal to limit as h approaches 0 of sine h over h times sine h over h? Each of those we know is equal to 1 by definition. You learned that last year. So you could have applied the limit there without continuing to use L'Hopital's rule to get, right? Sine of h over h, the limit as h approaches 0 of that is just 1. And then you're applying that twice. You multiply that 1 by 1 and you're going to get 1. Or you continue using L'Hopital's rule a few more times. In any event, it doesn't really matter you writing out the steps because, again, this is just a multiple choice question. So that's what we got going on there. Okay, what else can I do for you? Do you want to go now to the free response, like 2021 number 6 or something? Or any other one? Any other free response? I definitely today want to talk about a type of problem that is common, and that's like the leaky bathtub problem, because I don't feel like we've done that enough, and I want to talk about that, right? It's not that bad. You got the rate that something's coming in and the rate that something's going out, right? So I want to talk about that.
I do remember this late and it was like awful.
I just remember the potato question.
Potato wasn't that bad.
It was not, but apparently everyone was.
Yeah, everyone was freaking out about potato because the differential equation was given in terms of, yeah, but it wasn't that bad. But anyway, Can I do a leaky bathtub problem?
Yes.
Okay, let's go to it. And I'm just going to choose from one of the random years. How about 20? Let's see what we got going on here. No, this was the potato, so I don't want to do that one. Let's see, 18. Let's see what 18 gave us. Here we go. Actually, I'm going to go back even further. I'm going to go to something that we haven't, have we done anything from like 2006 or something like that? Okay, so let's go back to, here we go. Hold on one sec. Okay, this will be a good one. This is from the 2006 AP Calc BC. Exam, and here's what we got going on. So they give us this graph here, and it says at an intersection in Thomasville, Oregon. So there's an intersection, right? Let's say that this is the intersection at from Bouquet to Centurion. Okay, so cars that are driving, let's say from Best Buy area, and they're coming at, and then they make a left onto Centurion. Okay, but it doesn't really matter. What they tell us is cars turn left at the rate of L of t equals 60 root t sine squared of t over 3 cars per hour over the 18-hour interval that they're giving us. Okay, they don't say when t equals 0 is. Maybe that's midnight. Maybe that's 6 a.m. I don't know. But whenever they start doing this, they're timing it for 18 hours, and cars are turning left at the rate L of t is equal to 60 root t sine squared of t over 3. And now really quickly, hold on, wait, let me see. Do they tell us that this is the graph of, they don't say that this is the graph of L of t. So anyway, it says, to the nearest whole number, find the total number of cars turning left at the intersection over the time. So if this is the rate that cars are turning left on the 18-hour period, how many cars turned left? Just the integral of that. So this isn't really a good leaky bathtub problem like I wanted, because you can't undo cars turning left. But this would just be the integral from 0 to 18 of L of t dt. And then you would plug that into your calculator and get an answer. Next, traffic engineers will consider turn restrictions when L of t is greater than or equal to 150 cars per hour. Find all values of t for which L of t is greater than or equal to 150 and compute the average value of L over this time interval. So for part B, we would set L of t equal to 150 and get your t equals A and t equals B. So let's just say that that's going to be there and there. I don't know how accurate that is, but let's, it's around 12 point something and 16 point something. I don't know, you would, use your calculator to get those A and B values. Then to find the average value of L av, which is the average value of L, is going to be equal to 1 over b minus a times the integral from a to b of L of t dt. What does that give you? What does that give you? The average value of L. Yeah, so the that would give us the average rate that cars turn left from A to B per hour. Because the integral from A to B of L of t dt is how many cars turned left per B minus A is time, per hours, right? So it's the number of cars per hour. So it's still going to be the rate at which cars turned left, but it's the average rate at which cars are turning left on that interval. Anyway, I'm gonna move on to another problem because in my head this was a leaky bathtub, but it wasn't, and I really want to make sure to hit that. So here we go. This was 2006. I think that was still valuable, but let's go to 2005 and see what they have. Come on, 2005. Give me something good to eat. Nope, 2004. Come on, 2004. Nope. That's easy. 2003, where you at?
Yeah. It's like going tournament, but we removed all
Nope.
the girls.
How about 7?
Well, not anymore, you're restarting.
Here we go. This is your basic one right here. Let me see really quickly if 2008 is going to be better to talk about. Yeah, I like this one. This is a good one, and I feel like this might be. So here we go. This is from 2009. Did we do this one about the rock concert? Okay, let's do this one. This will be a good one. Okay, the rate at which people enter an auditorium for a rock concert. So now what we have is people are coming to a rock concert, right? And the rate at which people enter an auditorium is given by R of t. That's the rate at which people are entering. So part A says, how many people entered? How many people entered? Well, when the concert begins at time t equals 2. T equals 0, they open the doors. So how many people entered? Well, because this is a rate at which people enter, total people entering is going to be the integral from 0 to 2 of R of t dt. And then you would, plug that into your calculator to get the answer for that. Now, part B says, find the time when the rate at which people enter the auditorium is a maximum. If R of t is the rate at which people enter, we're finding when the rate that people enter is a maximum. So what do we need to do with R of t? Say it again. No. Setting R of t equal to 0 gives us what? When what is a maximum? Yeah. Correct. We're trying to find when the rate is a maximum, not when the number of people is a maximum, but when the rate is a maximum, right? So r prime of t equal to, so set r prime of t equal to 0 and solve for t. Okay. Now part C says the total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function W models the total wait time for all the people who enter the auditorium before time t. The derivative of W is given by, so now they give us this, W prime of t equals 2 minus t times r of t. So what they're asking in this part is find W of 2 minus W of 1. What does that represent? W of 2 minus W of 1.
Integral?
So what we're looking at is this, right? We're looking at this is just the integral from 1 to 2 of W prime of t dt. Would you agree with that?
Yes.
Okay. So so let's talk about that. I'm going to give you a couple minutes. I'm going to pause my recording. I'm going to give you a couple minutes, and I want you to work on that. Try to do that. Okay, so it's been a couple minutes, and what did you guys do in order to find? I kind of got you started with giving you this, right? And then I put down here what r of t is equal to. So really, W prime of t is equal to 2 minus t times 1380 t squared minus 675 t cubed. Did you guys distribute this first to get what W prime of t is equal to, or did you just leave that as W prime of t and plug that in your calculator? Yeah, you could leave it because this is a calculator active question, you could just plug that in. So what you're going to do is in your calculator, you're just going to maybe plug this into, let's say, y sub 1, right? And then you're going to find the this where that is in y sub 1. So this is just going to be the integral from 1 to 2. And then in your calculator, you're going to plug in vars, y vars function of y1. And then what did you get as that answer when you plugged it in?
387.5.
387.5. People at home. Hold on, I got to see you first. Did you get about 387.5 or something like that? Okay, good. And then part D asked us, it says, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. So let me just show this to you, and then I really want to get to one more FRQ. I think it's 2013. So this is 2009. Let me just bring up the scoring guidelines to talk about this. So what they are doing for part D is so you're gonna say given the fact that from part A, remember part A asks us to find how many people are in the auditorium when the concert begins, right? And we got 980. So we are really looking for the total wait time per person. So if we take the total wait time, and really W of T is the accumulation of how much time people waited, right? And so W of 2 is over the entire 2-hour interval, how the accumulation of, so if I wait 10 minutes and you wait 20 minutes, accumulation there is 30 minutes. We waited 30 minutes, meaning I waited 10, you waited 20. Which in that case, you would have gotten in 10 minutes before me. You waited that first 10 minutes by yourself, and then I joined you, and then we both waited 10. So you waited 20, I waited 10, we waited 30 minutes all together. That's what the W function represents. And so W of 2 represents the total wait time per the total number of people that entered. And the total number of people that entered was found in part A as 980. So that's what we're doing here. That's where that 980 comes from part A, right? So again, to find W of 2, really you're going to do, that's going to be the integral from 0 to 2 of W prime of T. That's W of 2. And then, of course, we divide that by 980. So we get, on average, a person waits about, 3/4 of an hour, which is about 45 minutes for a concert. I mean, I think that's about right. You don't want to get there right when the concert starts, right? You want to get there a little bit beforehand. Some people wait a little bit longer or get stuck in traffic, whatever, and they get there. But anyway, it ends up being 0.775 or 776 hours. Okay, good. The last one I'm going to talk about, and this one really, because that one wasn't really a good example either. This one's going to be a much better example. Here we go. Gravel. And by the way, all of these problems are AB, except for the average value. That was not an AB concept. Average value of a function is BC only. So here we go. On a certain workday, so this is from the 2013. Did we do this one already? Okay. So on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T. So again, this, if I were to mark this up from the beginning, G of T is rate gravel arrives. Okay. Now we're going for the 8-hour workday from T equals 0 to T equals 8. Let's say that's from, usually that wouldn't be from midnight to 8 a.m., but maybe it is. Maybe they're arriving having the gravel arrive, from 0 to 8 in the morning, or from midnight to 8 in the morning. Or maybe not, maybe start it, but it doesn't matter. At the beginning of the workday, the plant already has 500 tons of unprocessed gravel, like from the day before, right? And during the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So, the plant processes gravel at 100 tons per hour. Okay, so gravel's coming in throughout the day at a rate given by G of T, which is some function. They're able to process, they have the machines where they're processing the gravel and getting it out of there at 100 tons per hour. So this is what I want to point out to you. You ready? Assuming no new gravel was coming in, that gravel was not coming back in, what would happen? They start off with 500 tons of gravel and they're able to process it at 100 tons per hour. Do you all see that after 5 hours, all the gravel that was already there is going to be processed? Does that make sense? Okay. However, that's not what's happening. They're able to process it at this rate, 100 tons per hour, but it's coming in at this rate, and they already had some to start with. Okay, perfect leaky bathtub problem. So, first of all, they get us started by saying, hey, find G prime of 5, right? And interpret the answer of that. So, G is already the rate that the gravel's coming in. It's easy to, evaluate G prime of 5. But what does that mean? So go ahead and do that. Spend a minute really quickly. Do that. You have your calculator. This is problem 1 on the FRQ, so you have your calculator. Go ahead and do that, but then explain what it means. So interpret your answer. What'd you guys get for G prime of 5? Is that what you guys got, negative 24? Yeah, negative 24.587. So how would you write that as, what do they say? It says interpret your answer in the context of this problem. So what does that mean? Well, that means that the rate that the gravel is coming in or arriving is decreasing at a rate of 24.587 tons per hour when t is equal to 5, right? So the rate that gravel is arriving is decreasing at 24.587. Let me say this units correctly. Tons per hour per hour. There we go. Tons per hour per hour. Right? Because the rate that the rate changes is tons per hour per hour. There we go. Find the total amount of unprocessed gravel that arrives on this workday. Oh, that's easy, right? Part B is easy. It has nothing to do with the fact that they're processing it, just how much arrived for the entire day. That's easy. It's just the integral from 0 to 8 of G of t is the rate at which it comes in. So of G of t dt, which is approximately equal to about 825.551 tons when you just plug that in. So that's
So would you not add the 500 because that was already there before?
correct. It's only the gravel that arrives. The 500 tons did not arrive. That was already there. So G of t is the only thing that gives us the rate at which the gravel arrives at the plant. So you would not add in the 500 to it. Okay, so is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5. So what are they asking for here? What are they asking for? The amount of unprocessed gravel. Is it increasing or decreasing? But what rate? So here's what it is, right? G of t is the rate that gravel is coming in. What's the rate that gravel is being processed? Yeah, let's call that like negative 100, right? Because that's really what's the rate that it's leaving the plant, right? It's being processed and then it's done. So if we find G of 5 is the rate at which gravel is coming in at t equals 5. And let's compare that to 100. What happens if G of 5 is like 107? Then the amount of gravel, it's coming in at 107 tons per hour, but it's being processed at 100 tons per hour, so the amount of gravel is increasing. If G of 5 is 95 tons per hour, then what that means is that the rate that it's coming in is 95, but you're processing it at 100, so therefore the total amount is going to be decreasing, right? So it is this, some would say if G of t minus 100 is positive, because what is G of t minus 100, people? You guys at home want to try to take a stab at that? What does G of t minus 100 represent?
Is that like wait, it wouldn't be the total, would it, at that,
The total what?
like the total amount of gravel being processed?
The total amount of gravel being processed is 100 tons per hour, or that's the rate. But G of t is the rate that it's coming in. 100 is the rate that it's exiting, or negative 100 if you want to, think about it as. So it's the rate at which the total amount of gravel at the plant is changing, right? Does that make sense? You have a certain amount of gravel at the plant. We started with 500 tons, right? But then there's a rate that it's coming in and a rate that it's exiting, right? Being processed. Coming in is G of t is 100, right? Or if we call it negative 100. So if G of t is greater than 100, then that total amount of gravel at the plant is increasing. Leaky bathtub. You got the water coming in and the water that's leaking out. If the water coming in is greater than the water leaking out, then the total amount of water in the bathtub is increasing. We don't have water here, we have gravel, right? So if the rate that the water, that the gravel is coming in or arriving is greater than the rate that they're able to process it, then the total amount of gravel will increase. If the rate that the gravel is coming in or arriving is less than the rate that they're able to process it, then the total amount of gravel at the plant is decreasing, right? Go back to C, and what does it say? Is the amount of unprocessed gravel at the plant increasing or decreasing at t equals 5? So all I'm saying is you're comparing G of 5 and 100, right? Or you're looking at G of 5 minus 100. G of 5 minus 100 is the total rate that the amount of gravel, unprocessed gravel at the plant is changing. So anyway, G of 5 ends up being like 98 point something, I think. G of 5 ends up being 98.140764, which is less than 100. So therefore, I'll read you exactly what they say. They say this, you ready? At time t equals 5, the rate at which unprocessed gravel is arriving is less than the rate at which it is being processed. Therefore, the amount of unprocessed gravel at the plant is decreasing at time t equals 5. Does that make sense? That should make sense. Okay. D. What is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Let's talk through this. What are you guys thinking?
I think you would set G of t minus 100 equal to 0 to find the maximum.
Okay, that's a good starting point. And Lauren was saying the same exact thing as you said that, Claire. So the whole, right? Because again, G of t minus 100 is the rate at which unprocessed gravel at the plant is changing. So if you set that rate equal to 0, again, G of t minus 100 is the rate at which the unprocessed gravel is changing. You set that equal to 0, and you're looking for the time in time values in between 0 and 8. But because they're asking for what is the maximum amount on this closed interval from 0 to 8, or on the workday, what else do you have to consider? Not only those values, but the endpoints, 0 and 8. So what we're looking for is the total amount of gravel at the beginning of the day, at the end of the day, and when G of t minus 100 is equal to 0. So let me actually bring up the scoring guidelines here for you guys, because I know the time is getting very close, but I wanted to show you. So let me. So this is what they have going on for D. The amount of unprocessed gravel at time t is given by A of t, which is the amount of unprocessed gravel, is equal to how much unprocessed gravel you had to start plus how much that unprocessed gravel is changing. So what they do is they say that that's equal to 500, your starting unprocessed gravel, plus the integral from 0 to t of, they call it G of s minus 100 ds. It could have been any other variable other than t, because we're using t as this upper limit of integration. They then say a prime of t is equal to G of t minus 100. This is the big thing, that a prime of t is equal to G of t minus 100. And that gives us that a prime of t is equal to 0, or G of t minus 100 is equal to 0, when t is equal to 4.923480. Then we say how much gravel was at the plant at t equals 0, at t equals 4.923480, and at t equals 8. And then the greatest value out of all of those is the maximum value of unprocessed gravel ever at the plant. So here's what happened in this workday, guys, in this workday. Just with the rates given, the rate that the unprocessed gravel was arriving, they started with 500 tons before they even started the workday, right? Before they arrived, the people in the other shift or whatever it is, there was 500 tons of unprocessed gravel when the workers arrived. They started working and boom, right away started processing the gravel at 100 tons per hour. However, more gravel's coming in as they're processing it. So the maximum amount of gravel that was ever there was 635 point something tons. But at the end of their workday, they had 525.55 tons of unprocessed gravel. So when everything is said and done, the total amount of gravel that came in was 825.551 tons. The total amount that they were able to process was 100 tons per hour for their 8-hour shift, so 800 tons. So of course there's going to be more gravel there at the end of the day because they got 825 tons in and they were only able to process 800 tons worth, right? So that's what this is representing in this problem. Okay? All right. Guys, on Monday, so look it, over the weekend, again, everything that I've kind of shared with you on my, in my Google Classroom that's here, I really, really, really think it's beneficial to you to focus on a little bit of each of those. There's also that YouTube channel that if you just, you know, look at YouTube and you're looking at the AP Calculus, BC, there are all of these videos that pop up for, you know, they're like 11. They're all of these, putting it all together, working with tables, all of the, so these are the same things that I have for the worksheets on my Google Classroom. So that's another very beneficial thing for you, or whatever else you want to do in terms of Khan Academy, whatever. Be here at 7 a.m. on Monday and come to J1012, 7 a.m. Make sure you have your ID and you've done all the registration and everything, and we'll get you going from there. Have a great weekend. Good luck. I'll see you on Monday, AP Day.
Everything.
And
I need a time machine.
That's all I need.
I need a time.
basically